So what we're going to do now is we're going to start looking at transformations, and a lot of students really struggle with transformations, and that is why we're going to take our time and break it down into each type of transformation. So hopefully you watched the last video, which is essentially the parent functions, functions you should recognize just by looking at them. Now we're going to talk about how we shift them right or left, up or down, make them shrink or expand, etc. So obviously here we're looking at horizontal and vertical shifts, which means I have say a parabola, and this is my normal parent function parabola, and all of a sudden I have a new function written here, which means it got shifted to the right and shifted up, and that's what these horizontal and vertical shifts are all about. So if we have a horizontal shift, that's this direction, right or left, we're going to look at an h value. So f of x minus h, and this might not make sense to you yet, but we have talked about function notation and how we can plug in, some number, x minus 2 or something, into our function. That's what we're talking about here. Keep in mind that h is, because I have x minus h, if h is positive, it's going to look negative in my function, and if h is negative, then it's like f of x minus a negative value, and so it ends up looking like a plus. Whereas k, notice if k is positive, it's going to be plus. If k is negative, it's going to be minus. H adds or subtracts from the existing x value, so h is going to move it right or left, whereas k is going to move it up or down. And of course, this isn't going to make sense until we actually look at some examples. And I will point out right now that I do have a handout that summarizes everything that we're going to talk about in this video and the next several videos for all of the transformations of functions. So let's take a look at what h and what k do. And this one, I apologize in advance, it's going to be a long video. My parent function is f of x equals the square root of x. Now what I can see is I have two transformations of that function, and I've so nicely named them h and k to help you remember which one I changed in which place. But before we talked about h being f of x minus h. So notice inside the radical I have x minus 1. That means that h is positive 1, because h is always the opposite sign of what we see. Whereas we talked about k, or the vertical shift, being f of x and then plus or minus k. And so here, because it's actually a minus 1, then k is minus 1. Now h is a horizontal shift, so I'm going to focus on that one first. Here's my h. Now these two columns are the x and y values of just my normal parent function. So if you took your graphing calculator and you graphed y equals the square root of x, these are the first 5 points that you would come up with. So the question is, without having to get my graphing calculator out and plug in this function, can I translate, can I move the function? So what I know is that if I have an h value, it's only going to move right or left, which is of course my x's. So my y's here are going to stay exactly the same. Nothing is going to change with my y's. With my x's, I have an h of plus 1, positive 1, which means 0 becomes 1, 1 becomes 2, 2 becomes 3, 3 becomes 4, 4 becomes 5. So everything just got shifted to the right one position, which is what an h value of 1 would do. Let's look at my second transformation. My second transformation has a k of negative 1. A k will move it up or down, which means it's only going to affect the y's. So 0, 1, 2, 3, 4 will remain exactly the same. And my y's will decrease by 1. So negative 1, 0, 0.4, 0.7, and 1. So I just took my original y's and subtracted 1, whereas when I did my first one, I took my original x's and added 1. Now I want to graph these in Desmos.com and just verify that the work I did is correct. So what I'm going to do is I'm going to go ahead and just type in y equals, and then I'm going to use this square root function down here, and then x. And as I can see, that does graph that function for me. And I can also, if I want to, use that handy trick that says make a table. So again, -2, -1, those are undefined. Those aren't even on my table. 0, 1, 2, if I want to check 3 and 4, I just type in 3 and 4. And I can look at those numbers that I came up with and feel good about the fact that I did it right. Then I'm going to graph my g of x function. So y equals, and then I'm going to use the square root of x, square root function, then x minus 1. And as I can see, what it did, if I get this out of the way, what it did is it seemed to take this point and shift it, whoopsies, shift it from here to here, one position over. And if I look at my table, my first point would be 1, 0. I can do the same thing I did before and go to my settings and make it show me, go to my settings and make it show me a table. And again, -2, -1 are undefined. I can make it go to 3 and 4 and 5 to verify my values, but I feel pretty good about it. And then I'm going to do my last function, which is y equals square root of x, and then I don't want that -1 inside anymore, so I'm going to use this little arrow to get me out of inside of the square root function, and then -1. And then again, I can take a look at it, and what I seem to have is, what I seem to have is -1 here, 0, -1, 1, 0. This one's not going to show me, so I'm going to have to do my little trick again and go to settings and tell it to give me a table. So it's now going to give me 3, 4, and I can verify all of my values to make sure that I did my work right. And as I can see, and I can always get rid of this purple one to get it out of the way, what happened between my original and my new for the second transformation is that my original function got shifted down by 1. So each of those points just went straight down, whereas on the second function, each of my points went to the right one. So let's look at another transformation together. Notice here I didn't give you the table of values, but I still did give you what the transformed function is, which means my parent function, which is graphed for me, is y equals the absolute value of x. So that's that recognize basic functions. This is what your basic absolute value function looks like. I want to know what happens for this function, and of course I could cheat and just go in there and graph this equation in Desmos and then copy that graph over. But it's really important that you know how to do this, because sometimes I don't give you the parent function, I only give you the points, and you need to know how to deal with that. So here I can see that this is x minus 2, which means the h value is positive 2, because remember h is always the opposite sign of the way it looks, and k is always the same sign, so my k is 1, which means that I'm going to shift each, not shirt, but shift each value right by 2, because right is positive, and up by 1. So this point is going to become this point. This point went right 2, up 1. This point went right 2, up 1. This point went right 2, up 1, right 2, up 1, and right 2, up 1. So my new function looks something like this. So that's how we do it when we're just given a graph and we don't have the table. So I could go through and say this is the point 0, 3, and this is the point 1, 2, etc. But I don't have to, it just says to graph it. So here's the last one for you to try. And again, the parent function is obviously y equals x squared. I know that because I've got a squared here. So I want you to determine what's h, what's k, how is that going to change my existing x and y values from my parent function, which I got by just making up some points from there. So press pause, try this question, verify your results with a graph, and then press play to see how you did. So again, I would look here at the fact that this is x minus 2, so h happens to be positive 2 because it's the opposite of whatever sign I see. K is positive 3, and so what that tells me is my my x values are going to be increased by 2, and my y values are going to be increased by 3. So negative 2 becomes 0, negative 1 becomes 1 because I'm adding 2. 0 plus 2 is 2, 1 plus 2 is 3, 2 plus 3 is 4. For my y values, I'm adding 3, 4 plus 3 is 7, 1 plus 3 is 4, 0 plus 3 is 3, 1 plus 3 is 4, 4 plus 3 is 7, and then let's check those with the graph. Here was my original function, all in red, and I've made that little table to verify my original results. The 2 and 3 tells me everything got shifted to the right 2 and up 3, and I can see based on that that that's exactly what happened, right 2 up 3, and these values match what I came up with.